Hello and welcome to Statecraft IAS Academy. I am Atif, your geography educator. Super El Nino. You might be familiar with this word because this word has been in news for quite a few months now. And this has raised a few eyebrows as well. Since I already told you that in India, more than 50% of the population is directly or indirectly involved in agriculture. And monsoon plays a very important role in agriculture of India. When we talk of El Nino, it has a very severe impact on the monsoon of India. It causes drought-like conditions. That's what El Nino does. Now, Super El Nino, these are the enhanced conditions of El Nino. That means more drought-like conditions. That is why this has been a hot topic for past few months. Today, we will discuss El Nino, other important factors that are associated with it, and what is a Super El Nino. Are there any possibilities that we can actually nullify the impact of Super El Nino? That's what we are going to look in today's class. So we will start with the basics, understand this phenomena, understand other phenomena as well. Now, when we take a look at the oceans of the world, the sun heats up the upper layer of the oceans. The upper layer of the oceans are warm because of the sunlight. But the sunlight cannot penetrate up to greater depths, maybe up to a few hundred meters. But after that, you can see the temperature falling rapidly. The zone of thermocline, we will learn about this when we talk of the oceans. And this warm layer is very important for rainfall and other atmospheric features. Once the top layer is heated, then there is oceanic circulation. In simple words, if you take a look at this is Pacific Ocean. And this is where our concern is related right now. Because El Nino, La Nina, every phenomena that we're going to discuss now is primarily associated with Pacific Ocean. Specifically, Central and Southern Pacific. So we will focus on Pacific Ocean today. Now, listen to me. You know about the equator, an imaginary line that passes through the center of the Earth, approximately somewhere here, right? And if you have watched my first class, I told you about the trade winds, the easterlies that are present along this region. These are the permanent winds that are present along this region. Okay. Now, under normal conditions, first of all, you should know what the normal conditions are. Then only we can study the exceptions. Under normal conditions, this is how the things work. The winds drive the ocean water because the winds are present here. Now imagine these are winds. If anything comes in the way of the winds, what's going to happen? The winds will drive the water along with them. So I will drop a front wave as well, so that you don't get too much confused. This is South America here. This is Australia here. Okay. Now, this is Australia, Australia, and this is South America. You keep a look at both the images simultaneously so that you can understand it better. So normally what happens is that the water that is present is driven away by easterlies. Easterlies move in this direction like this. So the warm water will start to move like this. Why the warm water? Why? What do you think? Because as I already told you, the surface of the oceans gets heated up because of sun, especially this region. This is the equatorial region. Equator is the area where we have maximum solar insolation. So this is the region that will experience most insolation. Hence, the surface temperature of oceans will be higher slightly. When the winds or the easterlies will come, they will drive this surface water. Of course, see, it cannot drive the entire water till the bottom of the ocean. That's not possible. It will drive only the surface water. So what will happen? Once the surface water is driven away, the water will start to accumulate here. The warm water will start to accumulate here. Okay, I told you to look at both the diagrams simultaneously so that there is no confusion. This is the warm water that's accumulated here. Now, of course, at this very region, we won't have empty space. The water gets driven like this, but that doesn't mean we will have nothing here. The water from underneath will start to go up, what we call as upwelling of the water. So the water from beneath will start to go up. Now, the question is, if the water is going up, what's going to be the temperature of this water? Since I already told you the temperature of the water underneath is cold, it's not that warm. Okay. So when the water will come to the surface, it will be cold. Of course, eventually it will heat up. It will be driven away again, but initially it will be cold. Okay, clear? And you know, whenever the warm water is present, I'm specifically talking of this region. This is the place where we have warm water. There will be some air in contact with this water, right? The air will heat up as well. It's very obvious. If the warm water is present, the air in contact with it will be warm as well. So the air will start to rise. As I already told you, if the air starts to heat up, it starts to rise. It's not rising towards India. Don't get me wrong. It's rising somewhat like this. Okay. It will start to rise. Once it rises up, after some time, it will diverge and one branch will start to move like this and then come down over South America. One branch will go towards the other region that we will also discuss where it will subside eventually. This is the basic phenomena, normal phenomena that takes place in the in the Pacific Ocean. Why? Because the surface, simple words, long story short, remember this, surface temperature of the water is warm. The trade winds drive the warm water towards the western part of the Pacific or the coast of Australia. The warm water causes the air to heat up, the air rises up, and eventually the air starts to move in direction. Finally, it will come down over the region of South America. This is a normal circulation, or we call it as Walker's cell. Take a look at this image. Now, this is a much better image so that you can understand. This is South America. This is Australia. And this is the movement of water. These are the arrows that show the movement of surface water. Once they reach near the coast of Australia, the warm waters accumulate. The air above it is heated. So the air starts to go up. When the air goes up, there is a very important phenomenon that you already know because we have discussed it every time in every class. If the air is rising up, it will lead to formation of clouds. You can see the formation of clouds. That means this area will receive rainfall. The branch that moves towards South America will eventually come down. And you also know this thing as well, that whenever the air is coming down, it causes high pressure conditions. So, if you take a look at this, we have two phenomena near Australia. Number one is rising air. Okay, rising air is important for rainfall, cloud formation. Number two, warm waters, again that promote the rising of air. When we talk of the South America, you see the air is coming down. That means we will have high pressure conditions here, no clouds, dry regions. There is one more branch that moves towards west and then eventually comes down over the Mescaline. There is a region called Mescaline in the Indian Ocean. When it comes down over the Mescaline, it causes high pressure conditions here. It's very simple. You have to simply understand the air is going up near Australia, then it bifurcates. One branch goes towards South America, the other branch comes towards Mescaline. Mescaline is a region in Indian Ocean, somewhere here. So when the air comes down, it causes high pressure conditions here. This is something that is very important for our monsoon. Why? Look at this now. Look at this image. This is the Mescaline high that I told you. When we talk of India, you already know in summers we have very high temperatures. And if the temperatures are high, they are associated with low pressure conditions. Don't ask me why there is low pressure. I have mentioned this 100 times. So kindly don't ask such questions. Because the temperature is very high, the low pressure conditions or the troughs of low pressure develop over India. Now imagine we have high pressure conditions over Mescaline and low pressure conditions in India. I have told you the winds flow along a gradient. The wind will start to blow from high pressure towards low pressure. Okay, the wind will start to blow from high pressure towards low pressure, and high pressure is at Mescaline. Of course, the direction will be somewhat like this because you know the equator, then it will bend. Bending we have already discussed. We are not going to discuss why it's moving like this. If you have not seen the last classes, please go through them so that you can understand them. Okay, the winds will start to come towards India. Now, when the wind is blowing from Mescaline high towards India, it is blowing over the Indian Ocean, Arabian Sea, over the water bodies. So it will carry moisture. And because of this moisture, we see monsoon in India. This is a normal condition. If you look at this very image as well, you can see this is what I was mentioning you. The trade winds that are driving the water movement, and eventually the water accumulates at this very region. Clear? I hope this much you have understood. Eventually the air will rise, then it will move like this and will come down at this region. Now you understand why we have cold water here, because it's upwelled water that is upwelling, and one branch will go towards Mescaline high and subduct over the Mescaline, which will increase the pressure. This is something that is normal condition. Now, why do we call it as ENSO? You might have heard of the word ENSO. ENSO. ENSO is the El Nino Southern Oscillation. Okay, El Nino, we will discuss what El Nino is, but what is the Southern Oscillation? Now, what was observed by the geographers and the meteorologists in this region is that this condition that I have already discussed with you shifts. There is a change in this condition every few years, maybe 3 years, 4 years, 7 years, or even 10 years. There is a condition that is not like the normal condition every now and then. There is an oscillation. There is an oscillation between the normal condition and an abnormal condition. That is why it was called as Southern Oscillation. This is the Southern Pacific mostly where we see such things. Okay, so that is why it was named as El Nino Southern Oscillation. When we talk of Southern Oscillation, ENSO, we have three things that are associated with this. Three things. Okay, three things. One is the normal condition. I am depicting normal condition with N. Okay, then we have two more conditions. One is called as El Nino and the second one is called as La Nina. Okay, normal condition. After a few years, you will see a shift towards El Nino condition. Then the thing will go back normal, La Nina. So there's a shift between the conditions. You will be confused, sir, what El Nino is, what La Nina is, how the things take place, why these things happen. I will explain you everything. You don't have to worry about anything. I'm here only. Relax. When we talk of these three conditions, you have to understand that because of the oscillation between these conditions, we call this as ENSO or El Nino Southern Oscillation. Okay. Now, you understood normal conditions that the winds blow, they accumulate the water along the coast of Australia. Then there is rising of warm water. Now, sometimes due to certain climatic factors, what happens is that the trade winds become extremely strong. The trade winds become extremely strong. So because of that, if you take a look at this, these trade winds become extremely strong. So they will drive more water. They will take more water along with them. If earlier we can see they were driving, for example, 100 liters of water. It's of course more, it's way more than 100 liters. Because the wind speed was 10 kilometers. I'm just giving you an example. Now the wind speed has increased to 100 kilometers. So it's going to take more than 1000 liters of water. That is a condition which we know as La Nina. La Nina. This is very important for you. Why? Because this was a condition that developed over the past I think, I'm not sure entirely, but last winter or something, there was a threat of La Nina. I will tell you how it impacts India's monsoon, how it impacts India's winter season as well, not only monsoon. Okay. Now, since the trade winds become extremely strong, you can see increased trade winds written here. So what's going to happen? It will drive a lot of warm water. Look at the warm water that started to accumulate at this very region. Huge amount of warm water will start to accumulate. So what will be the impact of this accumulation? It's very obvious. If we have more water, there will be more convection, more air will rise, right? Because more warm water, more heating up of air, more air will rise. More air will start to flow in two directions, like this, and like this. So more air will subduct over mascarenes high. So high pressure conditions over mascarene will start to increase. They will become very high. Ordinary, if we have high pressure conditions in mascarene region, the high pressure conditions will intensify. So this region will see intensified high pressure conditions, high intensity. Okay, is this clear? Hope this is clear. Now, listen to me very carefully. Once the conditions intensify in this region, so more high pressure, that means more winds will start to blow. More winds will start to blow towards India. So they will bring more moisture in India, and more moisture means strong monsoon. It means strong monsoon. Okay. Now you have to remember two things. First, high pressure conditions around the mascarene high, and number two, La Nina is associated with stronger monsoon. Strong monsoon. Okay. La Nina, strong monsoon. La Nina also impacts winter conditions as well. How? Listen to me. You know, we have Siberian cold winds that blow from Siberia towards India. But because of the presence of subtropical westerly jet in this region, don't ask me what is subtropical westerly jet. I have discussed this. We have presence of subtropical westerly jet in the North India region. Okay. In winters, it is over India. In winters, the subtropical westerly jet blows over India. When we talk of El Nino conditions, this is Australia, we have accumulation of large amounts of warm water in this region. Correct? Large amount of warm water develops, accumulates. That means very low pressure in such a region. Warm water, warm conditions, low pressure, obviously. Now, when we have low pressure conditions in this region, what's going to happen? This subtropical westerly jet gets attracted slightly towards this region. It starts to come slightly towards south. Let me clear this one second so that you can understand it properly. Low pressure conditions, intense low pressure conditions due to high accumulation of warm water. So this subtropical westerly jet that is blowing over India during winter, southern branch of subtropical westerly jet, I explained to you. Kindly go through previous classes so that you can remember all this. This will start to come more towards southern region, like this. Okay, it will come southwards, and the winds, the Siberian winds, cold winds, intense cold winds, they will come far south, because this is a jet stream that prevents these winds from coming. It stops them. It acts as a barrier. It acts as a barrier. This is a subtropical westerly jet. When the Siberian winds come, it acts as a barrier. Now, if this goes far south like this, so the Siberian winds will also come far south. So these cold winds go over North India. They bring very cold conditions during winter. Very cold. If you are aware of the recent winters, 2025, you might have heard of severe winters. I recorded a few classes on this as well on YouTube. Severely cold winters were observed in certain parts. That is the impact of La Nina on the winters in India. The question is that this is not the only thing that Siberian winds will come. There is one more thing. When we talk of subtropical westerly jet, it will bring along with it the extratropical cyclones or western disturbances. We will learn about that in a few classes, maybe next class or sometime. A western disturbance will come towards India. If you're not aware of this, unfortunately, right now, I cannot explain you that. because it's a very big concept. It will require one class separately. I will bring to that, maybe next class will be on that thing. So western disturbances will come along with this, and they will also come towards India. Now what will western disturbances do? They will cause rainfall in North India, UP, Bihar, Delhi, Madhya Pradesh, sometimes seen up to Nagpur as well, as far as south in the Nagpur. And it will lead to snowfall in areas like we have Uttarakhand, Himachal, Jammu and Kashmir. These areas will receive snowfall. Along with that, that's number second. These are two conditions. What first condition we have is southward shift of subtropical westerly jet. This is the subtropical westerly jet. They bring along with them western disturbances. What will the western disturbances do? Rainfall and snowfall. Now it's very obvious. You can understand this very easily. If in winters, we are talking of winters, when we have rainfall in winters, the temperature falls. When we have snowfall, the temperature falls. I can tell you, I can assure you, since I live in Jammu and Kashmir, I can tell you when the snowfall takes place, it's very cold. So the temperatures fall, the winters become intense. Along with that, we have certain phenomena associated with the western disturbances or extratropical cyclones that lead to clear skies. After the snowfall, we have clear skies, the cold sector. What is the reason these clear skies are there? We will discuss that. But these clear skies, what do they do? There is the radiation that comes from sun towards earth. But when we have clear skies, there is no radiation that is stopped. It escapes. Hence, we have very cold winter nights. Long story short, these three factors are responsible for very cold winters. Now, you might wonder, why am I discussing about this? Because this was a condition that was observed just a year back. So that means it is still can be asked in your exam. It is still relevant for your exams. You might be asked the question, how is La Nina causing intense winter conditions in India? So you have to take these 3 points, explain them, whatever I told you, shifting of the subtropical westerly jet, western disturbances and clear skies. These should be your 3 points associated with the cold winters and La Nina. I hope you have understood La Nina for 2 important reasons. 1, intense monsoon. 2, intense winters. Simple as that. Now we come to the third phase. I told you, when we talk of ENSO, we have 3 phenomena that are associated with this. What are they? El Nino, La Nina and normal conditions. Now we will talk of El Nino. See, the first image is an image of normal condition, where the trade winds are blowing. They are causing the water to accumulate in this region. And the air rises, goes over mescaline, subducts there, and then causes the winds to blow towards India. This region we have cold conditions. Because cold conditions are here, so we have dry conditions. But I told you about the oscillation. After every few years, we see the reversal of conditions. Now look at the second image. What you can see here is that the warm water, instead of getting accumulated around Australia, starts to accumulate in the Central Pacific and the Eastern Pacific region. Ideally, this should have been the region of cold water. But now it is a region associated with warm water. This is a region associated with warm water. My question is, why does this happen? Because the trade winds that used to drive the water towards Australia become weak. When the winds become weak, who is going to drive the water towards Australia? If the winds are not present, winds were primarily responsible for that. They are not able to drive the water. They are weak. So the water will start to accumulate towards South America. There might be one more question in your mind. Okay, sir, we agree that the trade winds become weak, but they are not able to drive water from warm water here. But why is the water starting to accumulate here? What is the factor? What is the reason? It is because of counter-equatorial current. See, I tell you something very simple example is there. When the water is driven between the two regions, like this, so the water will start to accumulate slightly in this region. Once the winds disappear, the water will start to flow back. I have one very beautiful example for this. Look at this image. This is a fan. Okay. When the fan is switched on, this is switched on, what happens is that the water will start to go like this. Okay. It is accumulated at this very region. But what will happen once you switch off the fan? What will happen? The water that were raised slightly in this region will flow back. It will come back. You can see once it was like this. Now since the fan is turned off, the water will come back. You can try this thing at your home as well. You try this thing at your home. You take a bucket, you blow the fan from one side, you see the water will move. But once you switch off the fan, the water will come back. Okay, because a gradient is created, it will rise on this and then it will come back. The same thing will happen here. The water that was accumulated at this region will now come back once the winds will start to weaken. Or you can assume that this is Australia and this is Peru Chile coast. Ideally, we have less water, cold water, and the water starts to accumulate in this region. Once the fan is off, you see the water gets accumulated at this region. Same is the phenomena that you experience here as well. Am I clear? I hope this is clear with the help of the fan example, why the water comes back. Why is there a backflow? Because of this thing. Once the winds become weak, this is a condition known as El Nino. El Nino. Now, tell me something. When the conditions will reverse, what do you expect? What do you think there? Now, let me draw this for you first. This is Australia. This is South America. Right? What's going to happen? Now we have warm waters in this region and slightly cold waters in this region. So earlier the warm air used to rise from here. Now the air will rise from here. Now the air will rise from here and will come down at this region. Okay. If you take a look at this image, take a look at this image properly. The entire Walker cell will reverse. Earlier it used to rise here. Now it will rise at this region. So it will come down here. No cloud formation at all in this region. No cloud formation here. No rainfall. Rainfall will take place along this region. Clouds will form here. And this will also be absent. This branch will also be absent. Hence, the high pressure conditions that used to be formed around the mescarine will become weak. Weak high pressure conditions along the mescarine high. Or you can take a look at this image. Earlier, because of high pressure conditions, the winds were driven towards India. Now the pressure will be high here. This is a permanent high pressure system, but the intensity will be less. Hence, the winds that will blow towards Indian subcontinent or India in the monsoon season will be less. It will hardly be, maybe half of what it used to be, or even less. Hence, the winds that used to bring moisture to India will be highly reduced. That is why you will observe whenever we have El Nino conditions, we see drought. We see drought-like conditions over the Indian subcontinent, especially India. Now, I hope you're able to link the two. Now, one more thing, how we measure this. There is a Southern Oscillation Index that is used to measure the pressure differences and then predict whether we are going to witness El Nino, La Nina, or normal conditions. Two places where we observe the high pressure and the low pressure. This is the Pacific Ocean. This is Australia. This is South America. There is a region in Australia called Darwin. This is Darwin. This is a place in Australia, Darwin. Okay. And we have a place in Pacific Ocean called Tahiti. This is Tahiti. These are the two regions. The pressure difference between these two regions determine whether we are going to witness El Nino, La Nina, or any other phenomena. How? In normal conditions, I have already told you, we have high pressure conditions in this region. Why? Because of the winds or the air coming down. When the air comes down, we develop high conditions. Here we have high conditions and we have low pressure conditions in this region. So whenever you subtract the pressure at Tahiti by pressure at Darwin, if the value comes out to be positive, it is known as normal condition. Why? Because pressure at Tahiti will be always high under normal conditions because the air is coming down. Don't get confused, the air is coming down, so the pressure at Tahiti will be high and the pressure at Darwin will be low. So when you subtract them, the value will be positive. This will be normal conditions. If we get a very big positive value, that means it is El Nino condition. Sorry, this is La Nina condition. When we get a positive value but a big value. Now imagine the conditions have reversed. The air starts to rise around this region, Tahiti region. So we will have a reduced pressure over Tahiti and increased pressure over Darwin. In that condition, we will get a negative value. And that is what we say we are going to witness El Nino in Pacific Ocean. Long story short, remember one thing, when you have negative value of the Southern Oscillation Index, it is El Nino. If we have positive, it's normal. If we have a big value positive, then that's La Nina. What is pressure difference between Tahiti and Darwin? Remember the two places. This is about El Nino and La Nina. Now we come to our important, that is Super El Nino, that is in news. Now the thing is that when we talk of El Nino, it impacts our monsoon. So you can only imagine if we have a Super El Nino, how is that going to impact the monsoon? Very intensely. Super El Nino is a condition when we see the temperature exceeding 2 degrees above the normal. So the definition, an official medium term for a very strong El Nino. It's classified when sea surface temperature in the central eastern equatorial Pacific Ocean. What is the central Pacific? Central, that means this, eastern means up to this region, and southern Pacific means around this region. When in this region we see an exceeding temperature more than 2 degree. Why are we concerned with 2 degree? Because ideally this region should have been cold because of upwelling. Normally the winds would drive the warm water. But since we have accumulation of warm water, and the warm water, if accumulated and the temperature rise is more than 2 degree, we call it as Super El Nino. It will lead to very severe impact on Indian monsoon. I will explain you that as well. Take a look at this image. We have seen Super El Nino conditions once in January 1983, 1998, 2016 also. So this is a map. This is a comparison map. If you take a look at this, this is South America. This is Australia. And you can see the red region. More the red, more the temperature. Remember this. If more red, then we have more temperature. So more temperature is towards central and eastern Pacific region. And the region around Australia becomes cold because of El Nino conditions, Super El Nino conditions. Hence, we will see drier conditions. This is one reason that Super El Nino causes dry conditions. This is one reason. But there is one more reason that you should know. That Super El Nino causes impact on weather throughout the world, not only on India. How? Look at this image. This is Indian Ocean. You can see slight yellow color here. That means the temperature is not that high. Ideally, it should have been high because this is the equatorial region. But the temperature is less in Indian Ocean during Super El Nino conditions. Now, how is that related to our monsoon? It is very obvious when you take a look at this. If the water is warm, there will be more evaporation. Correct? There will be more evaporation. When the evaporation will be more, once the trade winds will come, they will take the water along with them and bring rainfall in India. Right or wrong? Right. Okay. If the temperature is less, the evaporation will be less. Hence, when the winds will come, there will be less moisture available for them. Hence, there will be less rainfall over India. Overall, you will see it does not only impact India. If you take a look at this region here, in the North Atlantic region. You see it's green. That means the water conditions are very cold in this region. Again, if you apply the same logic, the conditions are very cold. Very little moisture available for the jet streams to carry. We have England associated here, other regions, and when the jet streams blow over these regions, they bring moisture along with them. They cause rainfall. If the moisture is not available at all, if the water is very cold, that means there is little moisture available. When we have very little moisture available in this region, we see there will be less rainfall in Europe, in England, in other regions, which will eventually lead to heat waves. Now you can connect the dots. We learned about heat waves in Europe. This year, we witnessed very serious, very severe heat waves. Thousands of people died. Temperatures exceeding 40 in a region where we would not see 35. Can this be a reason? Maybe. It can be. So everything is related whenever you study geography. Remember, everything is related. One phenomena is always related to other. That is why I needed to start from the very basics. Otherwise, it would have been very difficult for you to connect the dots. It will impact India's monsoon. El Nino, I explained you how it impacts. It causes low pressure conditions. It causes less high pressure conditions over mescaline high. Less water available for evaporation. Now the condition we have understood is super El Nino. You should differentiate between El Nino and super El Nino in simple senses that whenever the ocean surface temperature over the central eastern equatorial Pacific region, that means this region, okay, exceeds 2 degrees above long-term normal. Whatever is a normal condition, it is more than 2 degrees. We consider up to 2 degrees, we consider it as El Nino. More than 2 degrees, it's considered as super El Nino. And this year, we are up for it. We are going to face super El Nino. And unfortunately, India is a country that depends on monsoon. More than 55% of agriculture in India is dry zone agriculture, and it relies on monsoon for the water requirements. If a super El Nino strikes, you can imagine how it will impact not only the rainfall pattern, but agriculture and the livelihood of millions of people. Is there any relief for us? Is there something that can help us come out of this? Well, yes. Let me tell you something. There is a good news as well. There is a good news as well. Indian Ocean Dipole. This is something that can prevent the adverse effects of super El Nino. Listen to me very carefully. I'm going to draw a map. Very bad map, I know, of India, but this is how it is. Especially today, I injured my finger yesterday while playing cricket. Well, so kindly bear with this. Let me delete it. It's become too bad. It should not be this bad. Okay. Now, this is India. I'm going to explain you how the things work. Okay, this is India. We have Arabian Sea here. We have Indian Ocean, Bay of Bengal. Listen to me very carefully. Normally, what we see is the monsoon winds come from this region. Okay, since there is less pressure, there is less moisture available, so the monsoon is poor in case of El Nino and super El Nino, of course. Sometimes, what happens is that the temperature in Arabian Sea, Indian Ocean region on the western side, Western Indian Ocean. This is west, this is east. The temperature, the warm waters start to develop in this region. Okay, because of warm waters, we start to have more moisture availability, because when the warm water will be there, the air will start to rise. The rising air will start in this region. Okay, once the air will start to rise, what is going to happen? We will get low pressure conditions in the western part of Indian Ocean. Clear? Let's say this is equator. Okay, so we see warm water conditions in this very region. This is warm water, low pressure, low pressure. What will it do? What do you think? We have warm water everywhere in the Western Ocean, this region. Low pressure will attract winds. It will start to attract winds from everywhere. From here, the winds will start to come from Eastern Indian Ocean as well towards this region. Okay, it will start to come. India is already under low pressure. So, because of this low pressure condition, the air will start to rise and the moisture availability will help moisture laden winds to come towards India. And of course, once we have moisture laden winds, it can cause rainfall. Okay, why? Because of this warm water condition that develops in Indian Ocean. And we will have slightly colder conditions in the Eastern Indian Ocean. So the winds from high pressure, cold conditions will start to blow from every direction towards this low pressure, eventually towards India, and rainfall. The winds will rise. There will be convection rainfall. Look at this image. This one, second one. You see, this is warm water. It attracts winds from every direction. Warm water, the winds will rise because the air is warm. Warm water, warm air, cloud formation, rainfall over India. This is called as positive Indian Ocean dipole. Why Indian Ocean dipole? Why do we call it as Indian Ocean dipole? Dipole means two pole. We have two poles. One is a warm pole that's created in here, warm pole, and one is the cold pole that's created here. So we have two poles. So this is known as Indian Ocean dipole. In Indian Ocean, we get one pole, warm water, we get another pole, cold water. So this is considered as Indian Ocean dipole. Number one. Sometimes the conditions can be reverse of this. What we see is we develop cold conditions here in this region and warm conditions here. So low pressure will be here and high pressure will be here. Winds will start to blow in reverse direction like this. Warm water, cold water. So instead of winds coming to this region, the winds will go away towards this. Hence, the rainfall will take place over Indonesian islands. And we will see dry conditions, less moisture availability for monsoon winds, less convection and less rainfall over India. This is Indian Ocean dipole, the concept of Indian Ocean dipole and availability of moisture. Now, the thing that we have to discuss here is that one very important thing. Well, it's a good news for us. Indian Ocean dipole. Is it going to rescue India's faltering 2026 monsoon? So basically, this is an article in Indian Express where it talks of whether this Indian Ocean dipole will actually help us to recover from the impact of El Nino or Super El Nino. Not only El Nino, but Super El Nino. What's your thought on this? What do you think? Well, I will give you one brief example. I will give you a table. You should probably draw this table so that it might help you in long term. This is a table that will help you in long term. Let's talk of Enzo condition and Indian Ocean dipole condition. Okay, so we have La Nina and we have positive Indian Ocean dipole. Both the conditions cause rain, heavy rain. Let me draw this properly, 1 second, so that you don't get confused. Let's say the first condition is we have La Nina and positive IOD. This will cause flood. This will lead to flood. Why? Because both the conditions bring heavy rain. So both the conditions will complement each other. They will bring heavy rainfall. Second condition. El Nino and negative IOD. Now, this will bring very severe drought conditions. Why? Because both the factors contribute to drought-like conditions, less rain. So both the conditions will bring drought-like conditions. Now there is one more case where we have La Nina and we have presence of negative Indian Ocean dipole. In this condition, we might get normal rain. Why? There will be normal rain because negative IOD will try to decrease the rainfall, but La Nina will try to increase the rainfall. So they will nullify each other. So we will get around normal rainfall. Now we talk of this year. The condition that we are going to witness this year, that is El Nino and positive Indian Ocean dipole. This is a condition that we are going to witness this year. It is believed that when the two conditions occur together, positive Indian Ocean dipole is strong enough to nullify the impact of El Nino. El Nino might bring drought-like conditions, but positive Indian Ocean dipole brings more rain. Hence, they will try to nullify each other and we might get normal rainfall. Now, the question that you might wonder is, sir, this is about El Nino. Yeah, right, this is about El Nino. What about Super El Nino? I can assure you one thing, when we talk of Super El Nino and positive IOD, we will get rain. We will get rain, but it will be slightly below normal. Slightly. Not what we otherwise would have witnessed. In case of Super El Nino, we would have witnessed drought-like conditions. But because of positive IOD, that I just showed you the news article, I think, where did it go? Yeah, this one. This is talking of this. Can it rescue India's faltering 2026 monsoon? If you read this, you should go through this newspaper. I've got this cutting for you from July 3rd. Okay, read this. You can see the heading here. India's monsoon opened last month with a steep rainfall deficit. That means there was less rain. What's rainfall deficit? Less rain. Why? Because of the conditions developing. El Nino conditions, Super El Nino conditions. Strengthening El Nino, that is the factor responsible for deficit rainfall. But a lesser known phenomena, ocean phenomena, could still offer relief later in the season. So this is what he is talking about. Indian Ocean dipole, that is positive Indian Ocean dipole. This article is talking about positive Indian Ocean dipole, where it will offer slight relief. It will not do abrupt change. It will not lead to normal rain, but it will provide some relief. I mean, it's better to have something than nothing. Right? You will say, sir, why isn't it giving us everything? I agree. But the thing is that it's better to have some rainfall than zero. Productivity will slightly be improved because of this rain. So this positive IOD is something that the meteorologists, agriculturists are looking up to now. They look at it as a last hope. They consider that this might actually help them come out of the problem of Super El Nino. And that's true. If it develops well enough, it might actually help. Now the question is it going to develop? I got a satellite image for you. See, this is India. And this is the Western Indian Ocean. This is Eastern Indian Ocean. Now, the blue color indicates cold water and the orange reddish color, I don't know what it is. So this indicates warm water. This is a satellite image taken just a few, I think, days back, and it is visible here that the temperatures in this region are increasing. We are getting warm waters in Western Indian Ocean and cold waters are present along with this. Why do we get, you might actually sometimes wonder, why do we get cold waters along the east? Because once the warm water develops in this region, the winds start to blow like this, from cold towards warm. Again, the same concept, there will be upwelling and hence the cold water. this might actually improve our agriculture with convectional rainfall, availability of more moisture for the winds coming from the masculine. Although the winds will be less because of less high pressure conditions, but still we will see some winds coming with high moisture availability. With development of Indian Ocean Dipole, it will eventually lead to good rain. We have one more condition called Madden-Julian Oscillation, MJO. It also plays its role in the Indian monsoon. It has two phases: convective phase, which leads to high rainfall if it is present over India during monsoon season. It is a pulse of moving clouds along the equator. Right now, we don't have to go into that because this is something that you need right now. If we get time, we will discuss MJO as well. But today's main aim was to understand, to find out the relation between the El Nino, Super El Nino, and Indian Ocean Dipole. You please remember the table that I formed here. Go through this multiple times. If you have any confusion, kindly let me know, because this is the table that will help you understand better. La Nina, positive IOD, flood, both the conditions enhance rainfall. El Nino, negative IOD, drought, both the conditions suppress rainfall. La Nina, negative IOD, one condition is a favor for rainfall, one condition suppresses it. So we get a normal rain. El Nino, positive IOD, they also counterbalance each other normal. But this year, we are witnessing super El Nino. But thank God that we have also a good positive IOD that's developing in the Indian Ocean. I hope you're clear. I think I did mention it or not. Whenever we have warm temperatures in Western Indian Ocean, that is positive IOD. Simple words, positive IOD, positive for Indian monsoon. Okay? Negative IOD, negative for Indian monsoon. Simple as that. So these are the conditions that you should know, and this is the article that you should read if you get time. If you're appearing in mains, if you're appearing for any exam, any civil services exam, kindly read this article. This is a very beautiful article from 3rd July that will clear your doubts how the IOD develops, how it impacts. Although I have explained to you everything that is mentioned there, but still it's good for your vocabulary and everything. You should read newspaper. It improves your answer writing and other skills as well. You get a hold of good words, your vocabulary increases. That's all from my side. I hope you have understood the relation between IOD and other factors. Super El Nino is clear, 2-degree rise in the temperature. Still, if you have any doubt, kindly let me know in the comments. I will get back to you. Till then, see you. Bye-bye.